let's chat a little bit about complex numbers. Now, the formal definition is that we're going to use a symbol, I, to be the square root of -1. That means I squared is equal to -1. You can do a lot of math with those two pieces of the definition, but what we're going to focus on is graphing complex numbers, okay? And graphing complex numbers on something called the complex plane looks a lot like graphing ordered pairs, but you do not write numbers as ordered pairs. You write real numbers going out this axis, and you write imaginary numbers going out this axis. So if I had the number 3, that would be 1, 2, 3, that would be out this axis. If you had the number 3i, that would be here, or 5i, that would be here. Okay? -2 would be there, -4 would be there. Now, the complex plane allows you to write numbers that have both a real part and an imaginary part. So, for instance, this point here would be 3 plus 5i. 3 plus 5i. And this single dot indicates that you have 3 in the real direction and 5 in the imaginary direction. And then you could see that this dot here would represent -2 plus 3i. Okay? Now, in the complex plane, you might say, well, what's the imaginary part of this? Well, the imaginary part is 0i, so we don't usually write that. But you could write this point as 3 plus 0i. In other words, 3 over 0 up. The nice thing about writing it like this instead of an ordered pair is you don't have an empty slot. You just write 3, and we know that that means there aren't any i's. Similarly here, 5i means you could write that as 0 reals plus 5i, because it's 0 to the right or left, and then 5 reals. And we can, of course, go into negative quadrants too. Let's put -2i here. So this point here is -4, -2i. Now, not shockingly, just like ordered pairs, we can add two of these things, and it means just like what adding means normally. So if I have -4 minus 2i plus, let's say, 5 minus 3i, you would add the real parts just as if they were ordered pairs, but they are not ordered pairs, right? 5 plus -4, -2 plus -3 is -5, and this would be another piece. Okay, you could subtract similarly, and the interesting thing here is that you can also multiply. Okay, and multiplying is perhaps the most subtle piece of this. If I want to multiply -4, -2i times 5 minus 3i, here's what I get. I'm going to distribute, so it's going to be -4 times 5, -4 times -3i. So that's -20, positive 12i. Then I distribute, some people say FOIL, -2i times 5, so that's -10i. -2 times -3 gives me positive 6. I times I gives me I squared. Now, I squared, if you remember back up here, I squared was -1. So if you have positive 6 times -1, that's -20 plus 12i minus 10i minus 6. You should always end up with a complex number, which is a real part and an imaginary part. The real part here is -26, adding those, plus 2i, adding those.